Okay, so the equation we're going to use is friction over the normal force is equal to mu. And so we're going to start off with a free body diagram of this situation. So this is going to be our inclined plane right here, and we're going to have an angle here, theta, and this is going to be our box or brick. So we know that there's the force of gravity going directly downwards here, so this is going to be F of G, and we know that the normal force is going to be perpendicular to the plank, so this is our normal force here, and then our friction is going to be going this way. And so now that we've drawn our force body diagram, what we're going to do now is we're going to assign F of G, so the mass of the block of the brick, a random number or a variable, and we're going to say that this is going to equal X, like that. And so what we know about this force body diagram is that it's at rest, right? So that's really important because since it's at rest, that means that all of the forces have to cancel out, which means that this friction here is going to be equal to the X component of gravity here. So wait, I'm going to draw it again right here to make it make more sense. So here we have our F of G, right? We're going to have a normal force here, and then we're going to have friction going like this. And so this right here, like this, if you look at it like this as if it were on a perpendicular plane like this, or on a, if you were to look at it as if it were on a coordinate system, and this was your X and Y axis, and this is F of N, F of G, and friction here, then your X component right here is going to be equal to your friction, and your Y component of your F of G is going to be equal to your normal force. So since we now know how this works, and that the object is at rest, and that this friction is going to equal this X component, and this normal force is going to equal the Y component of the FG, we now have to measure the angle of the inclined plane at the moment right before the block starts to slip. And the angle we got was 28 degrees. And so we got this angle, so that angle, this 20 degrees would be this angle right here, right? So this is the inclined plane right here, and this is the 28 degrees. And we know that this is a 90-degree angle, and we know that a triangle has 180 degrees. Therefore, this angle right here has to be 62 degrees, and this is 28 degrees, right? And then, if we were to draw out this angle, right, because we want to figure out this angle right here, so we can get the X component and the Y component, we know that this is 90 degrees, and this is the same exact angle, and 62 plus 90, which means that this has to be the same angle as this one. So we know that this angle right here is 28 degrees. So since we know that this angle is 28 degrees, now we can use basic trigonometry to figure out what these X and Y components are using the variable X for our F of G. So X sine of 28 is going to equal our X component, and X cosine of 28 is going to equal our Y component. And so if our Y component is equal to F of N, and our X component is equal to friction, now we have both our variables needed to find out what mu is. So now all we have to do, friction divided by the normal force is equal to mu. That means that X sine 28 divided by X cosine 28 is equal to mu. And so these two variables cancel out, so we just have sine 28 divided by cosine of 28, and that is 0.5317, and that is your mu.